Hello everyone. In homework 22 we look at special products and we'll start by reviewing the FOIL method. So remember, it's a memory device that's used to multiply a binomial by a binomial, and in general if we say a plus b is a quantity, that's a binomial, times c plus d, then remember the acronym FOIL stands for F is the first, O is outer, I stands for inner, and L for last. So when we look at this general situation of multiplying a binomial times a binomial here, we refer to the first terms as the first term of each binomial. So a times c would be our first. Let me give a little bit of room here because I'm going to have to make some arrows at the bottom as well. It's really called the double distributive property also, as you should recall. And the A was distributed to the B, or excuse me, to the C, but now we distribute the A to the D to get the outers. So that would be plus AD. So we're done distributing the A, now we distribute the B. So B is distributed to the C, and that's referred to as the inners. The outer meaning the outer product, inner meaning the inner product. So the inner gives us plus BC, and then we have the last term of each binomial to give us plus BD, and that's considered to be the last. So that's our FOIL method, as you should recall. So just reviewing that quickly here with some examples. I'll rewrite them. And take the A distributed to the first term, x being multiplied by x, that gives us x squared, and that's our first. The outer, x times negative 4, that's a negative 4x. The inner, negative 3 times x, negative 3x. And then the last terms, negative 3 times 4, negative 3 times negative 4, that is, positive 12. And then, as we've experienced on many occasions, we can combine the inners and the outers. So there's the outer product, there's the inner product. Notice they're like terms. So we'll recopy the x squared. And combining negative 4x and negative 3x, we get negative 7x. And then we just recopy the plus 12. Okay, so more examples. And you have to become proficient at this because in the next unit, what we're actually going to do is we're going to start with something like this, what is referred to as a quadratic expression, and we're going to decide where did it come from. So we're going to reverse the process of multiplication, which is factorization. But now we just want to make sure we master the concept of FOIL. So 3y times y for the first gives 3y squared. 3y times 2 for the outers gives positive 6y. Remember, put a addition or subtraction to separate the terms. Inner product, negative 4 times y, negative 4y. And then our last, negative 4 times 2, negative 8. And just as we saw in the last example, we can recopy that squared term, but now these outer and inner terms add together. or combine, in this case to give plus 2y, and then we recopy the negative 8. Okay, so kind of redundant here, I guess, but just more practice. I'll recopy 5x minus 2 is a binomial, times 7x plus 3 is a binomial, product of the first. Okay, so numbers could get large on occasion. 5 times 7, 35, x times x squared. Outer terms, 5x times 3, 5 times 3 is 15, carry the x. Inner terms, negative 2 times 7, negative 14, carry the x. And our last terms, negative 2 times 3 is negative 6. And so we'll recopy the squared term, combine the outers and the inners again, and that gives us 1x, so just remember you have to separate, so plus you could say 1x or just simply x, the 1 is understood, and then make sure you recopy the negative 6. Okay, here we see something a little bit different, because you got a squared term as part of the binomial, so let's just go through the process here. And so we take our y squared times 5y for the product of the first to give us 5y cubed. Take the y squared distributed to the 9 for the product of the outers to get plus 9y squared. 7 times 5y for the inner product, plus 35y, and then finally 7 times 9 for the last is 63. And again, separate the terms. But notice now in this situation that there's nothing to combine. That is, all of these are unique factors, y cubed, y squared, y to the first, and a constant term. So there's the outers and the inners are not like terms. Okay, so a special situation is a binomial squared. One of two ways you could do it. You could expand and use the FOIL method, or we can use a shortcut formula. So if you consider a binomial that's squared, we know that anything squared just means, like, for example, 5 squared means 5 times itself, x squared equals x times x, no matter what it is, even if, let's say, something question mark in a box squared means question mark in a box times question mark in a box. So it just means 2 factors of that thing. So since we're in parentheses here, this a plus b is a quantity squared just means a plus b times a plus b. So that's what we refer to as our expanded form. And then notice that it's just a binomial times a binomial, and we could FOIL. So a times a, bring it down here a little bit, we get a squared. Again, I want to leave some room for my arrows. The outer product, a times b plus ab. The inner product, b times a. You could say ba, but by the commutative law of multiplication, we could switch the order and say ab. And then the last product, b times b plus b squared. But notice that the 2 middle terms are the same, the outers and the inners again. AB is the same as AB. There's really a 1 in front of each of those. And so we can actually combine them. And we have that a squared plus 2ab plus b squared. And so that's actually the proof of our shortcut formula. So the shortcut formula is that when you have a binomial squared, such as a plus b quantity squared, you square the first term of the binomial, so we get a squared. You take twice the product of the two terms, so 2 times a times b would give us plus 2ab. And then you square the second term, so squaring b, we get plus b squared. So that's the shortcut formula. Now, not many people, especially when you're first learning this, will take the time to use the shortcut formula, but we'll show both ways, and I'd probably encourage you to just write it as a binomial times itself and FOIL it out. But we'll show both ideas. Okay, so recognizing binomial squared, we know it means that quantity x minus 3 in this case times itself, and we could FOIL. So we get x times x, or x squared. For the practice first, the outers give us x times negative 3, or negative 3x. The inner product, negative 3 times x, negative 3x again. And then the last product, negative 3 times negative 3, positive 9. So then we can combine the inners and the outers again. We get x squared minus 6x plus 9. And again, that's combining these two outer and inner terms. Now, by the shortcut formula, because remember I'll reiterate it here, a plus b quantity squared is a squared plus 2ab plus b squared. If you want to use the shortcut formula, you basically take the x, which is the first term of the binomial, representing a in our formula, and you square it, and then plus 2 times the product of the two terms, x and negative 3, and then plus the second term of the binomial, that represents b, negative 3 squared. And then that gives us x squared, 2 times x times negative 3, negative 6x, and then negative 3 squared is positive 9. And of course we get the same result. So it's your choice. You could use the shortcut method or FOIL. I think the majority of people probably prefer just trusting in FOIL rather than, because the shortcut formula almost seems a little mysterious. So just rewrite it as the binomial times itself and FOIL it out. 6x times 6x, 36x squared. I'll stop writing the FOIL. I think we're used to that by now. 6x times negative 7, negative 42x. Negative 7 times 6x, negative 42x. And negative 7 times negative 7 plus 49. And see, the reason why we say to take twice the product of the two terms is because the outer terms and the inner terms are always the same. So we recopy 36x squared, adding the 2, we get minus 84x, and we carry along the 49. Okay, so you could use the shortcut method if you want. I'm not going to show it for that one. Maybe I'll show it for this one since there's more room. But again, most people will just simply consider that binomial times itself. So anytime you see a binomial squared, just immediately react by rewriting it as that binomial times itself, and then go through the FOIL process. So 9a times 9a, 81. We gotta bring it down a little bit so I can show my arrows. a squared. The outer terms, 9x times negative 2, negative 18, 9a times negative 2, that is, negative 18a. Inner terms the same, negative 18a. And then the last term's negative 2 times negative 2, positive 4. And after you do this for a while, then you realize that, yeah, maybe the shortcut formula is easier because you're always combining these middle terms that are the same. So that's why we take twice the product. And you don't have to show everything that I'm showing when I use the shortcut formula. But the idea is that you take the first term, 9a, and you square it, and then plus 2 times the product of the two terms, 9a and negative 2 in this case, and then plus the second term of the binomial, sign included, quantity squared. So that's your a squared plus 2ab plus b squared in accordance with the shortcut formula. So you could see we get 81. So I'll separate this just so you know that that's the answer, we're done. But just to show it a different way, 81a squared, 2 times 9 times negative 2 is negative 36a. And then squaring negative 2, we get positive 4. And of course, we get the same result. So it's your choice, whatever method you prefer. And then we have something really special. And when we look at, in the next unit, the concept of reversing multiplication, that is factorization, this is a very special product that comes into play quite often. And we refer to it as the difference between two perfect squares. Now, as it stands, you can't see why we name it that, but when we go through the process of it, multiplying this out, foiling it, that is, then we're going to see why we call it the difference between two perfect squares. So, we'll set it up here as a minus b times a plus b, and we'll use the FOIL method. So a times a squared, a times positive b plus ab. Okay, minus b times a, you could say minus ba, or commutative law of multiplication, we could say minus ab, and then minus b times b is minus b squared. So then notice that in this case, the outers and the inners actually cancel each other because they're opposites. And so therefore, we get a squared minus b squared. And that is why we call this the difference between two perfect squares, because there's the difference, subtraction, and a and b are both perfect squares, a squared minus b squared. So in terms of the shortcut formula, which is something that once we look at factorization in the next unit, this is something that you're definitely going to want to memorize. The fact that a squared minus b squared, excuse me, we're not factoring yet, so we'll show it in the other order. But for right now, the product of a minus b and a plus b is just going to give us a squared minus b squared. So actually, if you recognize this, when you get to these types of problems, I mean, you could still do the same thing as always. FOIL is, like, if you know how to FOIL, that's half this exam, right? Because as we're seeing, it's reoccurring over and over again. Just simply FOIL when you see a product of two binomials. What happens is, we'll run through it the long way, but then I'll show you a short way to see this. I mean, you could just use the shortcut formula, or you could FOIL x times x, x squared, outer plus 3x, inner minus 3x, and the last negative 9. And then notice that the inners and outers cancel. They're opposites. And we get just x squared minus 9. If you wanted to use the shortcut, then you recognize it as being a binomial times, basically, this is a special name. We refer to it as the conjugate, okay? Nothing to really worry about right now, but you'll see that term come into play once you get into your next math course. Be talking about conjugates quite often. But you could just simply take the first term and square it, and then minus the second term squared. That's your a squared minus your b squared, as long as it fits that form. And then you can see we get the x squared minus 9 that way. And then even a third way to do this is that if you recognize the fact that it is this special case, of a binomial times, okay, again, the word is conjugate, then knowing that the outer and the inner terms always cancel each other, you could just take, if you set it up this way, you could just take the product of the first to get x squared and the product of the last to get your negative 9. Because you know the inners and the outers always will cancel. So it's really just FOIL without the vowels, right? FL, first and last. But when you're first doing this, you might consider literally going through the FOIL process. I know that's what I did when I was a student. I took to show it literally. In this example, we illustrate the fact that it doesn't matter the order of the factors. I know we had shown this with minus a minus b times a plus b, but it could be a plus b, a minus b. Still going to work out to be the same. X times x, x squared, x times negative 11, negative 11x, 11 times x, positive 11x, and then 11 times negative 11, negative 121. And once again, we see that the outers and inners cancel, and we just get x squared minus 121. Okay, and then you could do the shortcut method if you like, or you could skip the outer and inner products like I did in this. So it's your choice. But I think I'm going to show this going through the literal FOIL method, and if you want the other fancier techniques, that's great. But for now, let's just FOIL. So 3x times 3x, 9x squared. 3x times positive 2, positive 6x, negative 2 times 3x, negative 6x, and negative 2 times 2, negative 4. Once again, the outers and inners cancel, and we just get 9x squared minus 4. Okay, and then here's one that's a little bit different. We put the, instead of having in the binomial the x first, and then the constant, this switches it around. But really doesn't matter, you're just going to go through FOIL, right? 4 times 4, 16. 4 times 5x, 20x positive. negative 5x times 4, negative 20x, and a negative 5x times 5x, negative 25x squared. And as we've seen, outers and inners cancel, and we get 16 minus 25x squared. And notice that this is why we call it the difference between two perfect squares, because there's the difference, and 16 and 25x squared are both perfect squares. Same with 9x squared and 4, they're both perfect squares. Okay, and same with the other two examples as well, and it's the difference between them. So that's why we give it that formal name. Okay, so that's the end of homework 22. So we will see you when you are ready for homework 23.